Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
This week, we're going to continue our series on building addition facts through relationship and fluency through experience.
Ooh,
Today,
I like how you said that.
Oh, okay. Today, we're going to dive right into some of the most important relationships that we want to build in students.
Sorry for interrupting. I just really
That's
liked how you
okay.
said that. That was good. Building addition facts through relationship and fluency through experience. Bam. Man, I work
so
with good
funny.
people. All right, I want to start today. I just heard you say fluency.
Yep.
This word sticks in my craw just a little bit because I think there's like a lot of definitions floating around. In fact, Jenny Bay Williams and I were at a conference one time, and I had only barely met her. She probably had no idea who I was. And I was like, hey, I have a problem with the way the math community at large uses the word fluency, and you're in a position to help change that. And brilliantly, they just wrote this whole, she and John Sangiovanni just wrote Figuring Out Fluency. Did a really nice job. Can I take credit? No, I'm not going to take credit for that. But I did definitely chat with her about this idea that the word fluency, some people think means that I am good at procedures. And I want to push up against that and say, no. Fluency means that you don't get bogged down in it, that you are fluent enough in it, that you're not off to the side trying to figure it out and now you can't get back to where you were, that it sort of drags you out of the work you were doing in such a way that you can't then have sort of the conversation if you're talking about being fluent in a language, or that you can't do the mathematics because you sort of got derailed over here because it was bogging you down. Do we want students who are fluent? Everyone nod. Of course we do, but it doesn't mean that they are just like, oh, and now I can do the procedure without thinking. No. That's not fluent. That's a robot. That's a computer. We don't need those. We need thinking and reasoning human beings that don't get bogged down in stuff that we need them fluent at, the fluent with. And I just ended lots of sentences with a preposition, and I don't care.
It's so funny that you are mentioning this right now, kind of off the cuff, because it makes me think of one of my sons, well, I'll just say Luke, my older son, was in a situation where he was taking an IQ test, like a legit psychological evaluation, like the real deal IQ test, right?
Okay. My fave, not.
I've spoken about Luke before and how, he's a thinker and a reasoner and just amazes me, right?
I mean, I'll pipe in. He is an amazing mathematician. I have had some wonderful math conversations with him. Far above where I would think a student in his grade level would be.
Yeah.
Yeah.
Well, and so what I found interesting, so when we got the result of that back, one of his lowest, I'm air quoting, areas was fact fluency. It was a timed situation. I already talked about this in our previous part of our series about
how much we love time.
Yes, how much we
love. Yeah, no,
but
don't.
For such a great reasoner and thinker and, well accoladed for all the things math, it was one of his lowest areas because it was speed dominant. It was completely based on his fluency. They quoted it fluency. And I would argue that he is very fluent with his facts.
I would agree with you completely. Yeah. In fact, if anything, I can almost picture him going 7 times 8. That's it.
Mhm.
Okay. That's all you. Okay. 56. Like he
Yeah.
would be like trying to find what's hard in it. Like what
Yes.
am I
What's
supposed to
the
think?
point?
What am I
Mhm.
supposed to think about here? Oh,
Yeah,
nothing.
silly. Yeah.
Well, okay. I guess I'll just tell you that it's
Yeah.
56. Random.
Interesting.
I can totally
Interesting.
see him doing that. Yeah.
Yeah.
Yeah, now you know how we feel about IQ tests. All
Yeah.
right, so in anything where speed becomes like this important. Now, is speed ever important? Let's be clear. Probably in the basketball court, it's a little
Yeah.
important.
When you're driving down the road.
When you're driving down the road, you got to be. In fact, my kids. Oh, I love my kids. When, not all of them, but when they were learning to drive, some of them would slow down when doing things where they shouldn't slow down. And I'm like, you can't
Mhm.
slow down here. I'm trying to think of it. What's a good instance where you
On
don't
the
want to slow
highway.
down? What?
Getting on the highway.
Yes, yes,
Do
excellent. Or
not slow
changing
down.
lanes.
Yep.
Like, don't slow down. Like you can shall not slow down, not right now. And so but they're like, but I'm being careful. I'm like, you're
Yes.
gonna get killed.
Yeah.
Like this is not a time. So there are instances in life where speed is important.
But slowing
Not
down to be careful is a brilliant thought when you're thinking about math.
yes, yes,
Yeah.
yes. Yeah,
Yeah.
absolutely. Yeah.
All right. So
So
on to patterns, Pamela.
oh, yeah. So we're talking about patterns with addition facts, and that if we can help students identify patterns in addition facts, then that will help them automatize those facts easier, better, more, and be more fluent in those addition facts because it takes the onus off of so many to like get down. Oh, no, I can just think about those. I understand that relationship. I can just use that relationship. Woo! I'll just do that. And then all of a sudden we're sort of free to just think and reason, and we're not bogged down by speed pressure or by this sort of rote memory pressure. All we have to do is kind of use the relationships. And
Yep.
that is mathematizing, just as
Right.
an aside. And so we can do it with single digit facts. Cool. One of those patterns that we want to bring up today is doubles. Doubles are important. Yes?
Doubles are really cool.
Yeah.
So when we're
Oh, I have a story.
okay.
Can I tell a story? Sorry.
Yes, absolutely.
When I was beginning, okay, I'm going to give you a little bit of a view into my non-numeracy. When I started this journey, I was teaching high school math. I was doing technology training. I was wandering around the country helping teachers understand how to use technology to teach high school math better. I was doing a workshop, I'll never forget, in San Antonio, Texas, with a group of pre-calculus teachers. And we were dealing with a rational expression. So a thing divided by a thing. Kind of looks like a fraction, but it had variables in it. And one of the teachers said something about something 35. And it had to do with if we doubled the 35, it turned into 70. And then there was a nicer division that happened. And I was like, wait, what? And somebody said something about doubles. And I was like, oh, yeah, doubles are really important. But 35? Like it had never occurred when I was dealing with doubles. I was thinking what we're talking about today, which is single digit
Mhm.
doubles. It had never occurred to me that 35 was an important double. So we're not going to really go into higher digit doubles today, but we want kids to learn single digit doubles because doubles are important. And then later, then they can learn higher digit doubles.
So when you say we want kids to have some experience with them, some of that is just noticing them, right?
Mm-hmm.
Discussing that they're actually a thing in our lives. We have a lot of doubles that if we just notice. And one of the things that we really love is games with
Mm-hmm.
doubles.
Yep.
One of our favorites is a Cathy Fosnot game called the Shoe Game.
Yep.
So there's the mat, the playboard is just pairs of shoes. Kids roll a die that says maybe 5, and then they move their marker ahead. They have to think about it first, right? Like what's the double of 5? And so they have to consider 10. And so they move forward that many spaces.
Mm-hmm.
I love the differentiation of this game because there's a second die available. And if kids don't know the double of 5, then they can pick up the second die and turn it to the 5, and then they can count if they need to. So they would count the 5 and 5, or start with 5 and count up to 10.
Mm-hmm.
So they get to the end of the game board, they turn around, they come back, and the game ends with both students being back at the beginning of the game board. So that's one that we absolutely love, Cathy Fosnot. We give her credit for that game.
Yep.
It's
Nicely done.
fantastic.
Brilliant, brilliant curriculum writer, Cathy is.
Mm-hmm.
Yeah. And so we would love for students to have some experience with games. Kim, tell us about what is it called? Doubles?
Oh, doubles. Yeah, there's a double game. So a game board. Can start with single digit facts. They go up to 10 plus 10, I believe. So doubles has a game board that's like, I don't know, there's maybe
Kind of
15 to
looks like a
20
bingo
numbers on
board,
there.
right?
Yes, a bingo
Yep.
board.
Yep. Mm-hmm.
And it has just a bunch of single digit numbers on there. The kids roll.
Single and double. Yeah.
I guess it goes up to 10, maybe to 12.
I think
Um,
so. I've seen game boards that go up higher. So
oh,
you sort of
okay.
choose the game board that goes as high, I guess, as you
You really want to. Yeah.
I think so.
So, what I love about this game is that you can play with this particular board and play a couple of different games. So the doubles game is simply you draw a card. Oh gosh, I'm not even remembering.
Draw cards.
Now. Draw a card.
I think that's why you were thinking about the lower one. So you roll a die, and that's going to only go up till 12.
Yeah.
But you could draw a card, and that can go up as high as the doubles of your highest card.
Right.
Or you can spin a spinner, and I think that's the version I'm thinking of.
Yes.
You spin a spinner, and then you have other options of numbers that you can double.
So if you spin a 6, then you double it, and you put your marker on the 12. And so you go back and forth. That's the first level of it, right? The first version. The next part I really love, and it's more interesting to me, is that then you can play doubles +1 or doubles -1. So you spend the 6, you double it, you say 12, and then you say, I'm going to +1 or -1 to cover either the 13 or the 11.
Yeah, depending on what's free, right? And you can kind of think about that.
Mm-hmm, mm-hmm.
And with any of those versions, we love the fact that then after the game is sort of played, then you ask questions like, hey, what numbers did you cover? What numbers did you not cover?
Right.
What numbers will you never cover?
Mm-hmm.
And now we get to start talking. So I'm going to let everybody think about that for just a second. If we're playing the version where I spin the spinner, I double it, and I put my marker on that double, what numbers will I never cover on that game board? Kim?
Sorry, I was distracted.
If I play the first, that's hilarious. If I'm playing the first version of the game and I spin the spinner and I double it and I go cover that number, so we're just covering doubles, what numbers will I never cover?
I will never cover odds.
Odd numbers, right? Because you can't double a whole number and get an odd number. And then if I'm playing the plus or minus version, then I'm going to ask now all of a sudden I'm not covering any evens, right? I'm only covering odds. And that's so cool. And so we like games like that. They kind of have multiple levels of things going on. It can kind of keep some kids thinking that have had more experience and keep kids really learning that have had less experience. Brilliant, brilliant game. One of the ways I like to develop, maybe if your students don't know the doubles. So we kind of have said in the shoe game, there was the option that they could sort of match the die, and then that would help them if they don't know the double. But in the doubles game, if they don't know it, then maybe you could notice that as a teacher. And a way that you could kind of help develop doubles is to look at them on a number rack or a record rack. Mm-hmm. So for example, if I said, well, here's 7, what's double 7? So I move over 7 beads on the top. And then I would move over 7 beads on the bottom. And then I would encourage kids to notice the pattern of the 10 in there. So in 7, there's a 5. And so in that other 7, since I'm doubling it, there's also a 5. And I could pull out that 10. Mm-hmm. Well, what's left over? Well, the 2 and the 2. Oh, so I can think about that as 10 plus that leftover 4. And that can help me sort of think about doubling 7. So doubling single digit facts can be nice on a number rack because we can sort of have those 10s kind of pop, and it can be a way to develop them.
Yep.
Yeah, cool. And we don't want students to just know doubles. We also want them to know near doubles, right?
Right.
So sometimes I hear teachers say doubles plus or minus 1.
Uh-huh.
I'm okay. Okay, maybe I'm not. I was going to say I'm okay with that. I would prefer, if you don't mind, if you have to say doubles plus or minus 1, quickly move to near doubles.
Right.
So maybe it's, or just start with near doubles. But so it's about near doubles because then that kind of extends. I can get into bigger numbers now, and I can think about not just plus or minus 1 from a double, but I can think about questions like 32 plus 36. And I can say to myself, well, bam, that's almost 35 plus 35, but I'm down 3 and up 1. So I'm really just down 2. And so if I know double 35 and then I can just go down 2,
Mhm.
then I can sort of think about 70 minus 2 and I can get that 68 from a problem that was only near doubles.
Yeah.
And so I kind of want to keep it as, general enough. Anyway, so near doubles. Near doubles are important to work with youngsters.
Yeah, and it's really what you were just describing is some early work into could be the over strategy with
Mm.
near doubles.
Yeah,
And what you were
absolutely.
just describing was early work into give and take.
Yeah, absolutely. Yeah. And so
Yeah.
doubles are going to be really important to go there. Cool. What's another nifty pattern?
Yeah. So another pattern that we love is the 10 plus or the teens, the 10 and, which would have already happened in younger grades, right? So really early, we're talking about numbers composed of 10 and we call those the teens. And there's the whole weird like names for all of them. So students will already know things like 10 plus 5 or 10 plus 4, 10 and. But with the commutative property, remember we mentioned that earlier, that means they also know 5 plus 10 and 5 plus 4 plus 10.
Yeah,
So
totally.
making them aware of, oh, you know the teen numbers, so then you know the turnaround fact. And we have to do work to help them make a sense of that and know that they know. Like, you know this, and here's how you know this. And if you remember last week, we talked about allowing kids to mess with the number rack and flipping it upside down to help them cement that commutative property.
Yeah. So, for example, hey, let's just notice that we know 10, I pull over 10 beads on the top,
Yep.
plus 5, I pull over 5 beads on the bottom. We know that that's 15. So then now I've flipped the number rack upside down. So, do you also know what 5 on the top plus
Yep.
10 on the bottom? Oh,
Yep.
sure enough. And so now we can kind of make sense of some facts that might. What we don't want is students going, oh, what's 4 plus 10?
Yeah.
4, 5,
5
6,
plus
7, 8,
7.
and then counting it
Yep.
by 10. When they know 10 plus 4. If they know 10 plus 4, let's bring the community property in. Let's notice that, make sense of it. We are good to go. Cool. So another cool pattern, I'm going to let you talk about this one because I think this might be one of your favorite patterns, is to think about how we can add 9. How do you add 9, Kim?
Yeah. So we just mentioned the commutative property, right? To think
Mm-hmm.
about plus 10, like if you have 5 plus 10, then if you know 5 plus 10, then you can also just back up. And it's the over strategy. It's one of my favorite strategies. So if you know 5 plus 10 is 15, then you know 5 plus 9 is just one less. So 14. And that is early over strategy.
Bam. So just to back that up just a little bit. So if I'm dealing with a problem like 6 plus 9, then I might
Hmm.
say to myself, well, I know 10 plus 6. Therefore, I know 6 plus 10.
Yeah.
That's where you were talking about the commutative
Yep.
property.
Uh-huh.
So I know 6 plus 10. Well, that's 16. But I just need 6 plus 9. So I back up 1. Boop. Yeah, it's funny. Often I'll talk to people and I'll say something about plus 9, and they'll go, "Well, there's this funny thing. There's just," and they
Hmm.
don't even necessarily describe it all that well because they've kind of just been doing it in their head.
Yes.
We can make that much more what's the word I want, get it out of their head, make it not just something that's like living inside, but we make it visible, we pull it out so we can talk about it and make it we put it on a number line. Well, if I know 6 plus 10, big jump, is
Hmm.
16, then 6 plus 9, not such a big a jump. Well, how not so, just one smaller than that? Yeah, sure, we just back up one. So totally and you love the over strategy,
I do
yes?
love the over strategy. Yeah.
It's such an important relationship. And so the relationships we talked about today, so important to identify, explore, play with, and own. Y'all, in our next episode, we're going to talk about what's probably the most important relationship that we need kids to own as they are developing and really gaining and automatizing the single digit facts. So you are not going to want to miss next week's episode as we talk about the partners of 10. Hey, we've got a free download for you today. We are loving really working with y'all on the single digit facts. We have some important addition fact relationships, a free download for you so that you can really like focus on these important fact relationships for addition. You can get that at mathisfigureoutable.com/add relationships.
We also want to remind you that registration is currently open for our deep dive workshops. You can check
Woo!
those 4 workshops out at mathisfigureoutable.com math.figureoutable.com/workshops.
Yeah, and if you're listening to this at a different time, you can totally join the waitlist at that same URL, mathisforgettable.com/workshops. Be a great way to get on the waitlist, or take the workshop now while registration is open. It's an experience that I don't think you can duplicate anywhere as we dive deep into content at your level. So, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.